Daniel, how are you doing today?
I'm good, Gadi. How are you?
Oh, doing pretty good, pretty good. Please take it away.
All right. This is going to be a wild 5 minutes. For the last 2 years, we've been doing a journey on trying to map the path that cryptography takes in an application or a binary. These screens are wild. Bear with me, right? What we've been doing with Ben at Microsoft and Nick at GitHub, myself and Mark Carney, is building CodeQL queries that kind of take us through that journey. So if you imagine a bit of code here, so basically the general workflow is identify the language, the API, locate all the API invocations, trace and locate all configuration sources to and between invocations, right? So that's fairly simple. But we want to graph that out. And that's when it gets really messy. So these are the two overlaid. In theory, that's how we did it. And what we've done is to say, right, we've come up with a process where we built the CodeQL queries and we've run CodeQL to extract all the possible paths that crypto takes. And in this case, we are interested in the normal source sync data flow. So in this case, I want to say key flow into the sync, right? And I can pick up there and do the normal stuff. And it says, hey, I found all this stuff, happy days, right? Great. But we want to take it one step further. And this is where we've been doing a hell of a lot of research and we've been trying to build in capability with various models to try and make this a lot easier because CodeQL isn't the easiest. So what we've got at the moment is we built our Sarif output that you can see there. And then I've written a CodeQL print CBOM graph explorer. Now, 2 years ago, we released a tool that allows you to build CBOM from CodeQL output. GitHub's now using this with their normal GitHub Actions, which is pretty cool. And what this does is basically starts to create a graph and nodes and creates a DGML. Now, DGML is absolute hell for anybody who's ever dealt with it. So I'm just warning you, it's a right pain in the arse. But we've done that, and we've generated the CBOM graph that has color, all well and good, right? We then need to build some probes. Now, little history lesson, objects in OpenSSL can have a short name, a long name, and a numerical identifier, or a NID, right? Boring SSL makes use of OIDs, which is more standardized, but they also have NIDs. So it gets a little bit confusing because then you need to start mapping stuff. And also Boring SSL says that those are for insiders only. So mapping where the various things are is really problematic, right? So what we've done is we've got our DGML graph and we want to say, okay, let's just do really basic C. We're going to try and enumerate any specific algorithms, so MLChem 512, dilithium, Falcon, whatever. We do that. We do the same thing for our OID to NID, right? Really crusty C code. Do it and normalize it. And then basically what we want to do is have output, right, via a normalized script that gives me something that I can give to a large language model. And this is what we end up with, right? We have a prompt that we say preempting the model to do what we want to do. And I will show you how this works. And this is probably where most of the hell has been for a very long time. Why can I not find it? Freaking stupid. There's the bloody thing gone now. Right. I've created a CodeQL helper in ChatGPT, and I continually train that. So if anybody wants to get involved in CodeQL, they can. And what we do is we give it basically the two things, the environment.json and the events.json. Now, these are the two files that hopefully we can then start to build stuff up. Right, so we say you're compiling a cryptographic bill of materials from deterministic scanner events. The output must be valid JSON. Don't invent stuff because unfortunately this is a massive problem, and where possible showcase and explain where bad cryptography is present. And it does okay, right? It's sort of like in all the research that we've been doing so far, it's not bad, it's not perfect, but it's kind of saying, hey, yes, we sort of found something there and we think that, hey, this is observed, but there's no negotiated flow context. So you need to look into that. And that's all good, right? So probably the last couple of weeks have been spent trying to see if we can make this better for people. On the flip side, we've also decided to make graphs because I love graphs. So this is a small subset of OpenSSL where we can start to see an operation happening and how keys are made and so on, right? Very simplistic. But what happens if we take boring SSL? And this is where it gets complicated. So in this case, I've colorized it because it's easier to see, but you can start to understand how hard it is to map the proper path any form of cryptography journey takes in an application. And we will be presenting this at GitHub Universe next month, and we hope to have a lot of the CodeQL queries merged into main. But it's been a hell of a journey so far, especially playing with DGL and all the SSL stuff. And that's me summing up for a while.
All right. I don't see that we have too many questions in the chat, and I think that's because people are pretty much in shock. But
Yeah.
before I give it to Moon, context window?
Sorry?
Context window?
I'm not even playing with that. At the moment, I am struggling more with getting CodeQL to give me the stuff I need. That's the next phase. I haven't even played with Claude yet. I found GPT-5 to be fairly useful in this. But the plan is we're also going to be pushing it into GitHub Copilot. So eventually you would have a GitHub action, and then potentially you would have GitHub Copilot telling you where bad stuff is happening and where vulnerabilities might exist, we think.
Moon?
Yeah, I'm echoing. Shock is the right word. I wrote down on my notes. What? This, my first observation is really like your attempt to graph this has gone exactly like every attempt to graph networking and all sorts of other things for intelligence, where it's like it immediately explodes and then you go, oh, this is unworkable. But it looks like you actually have very good clusters to work with in terms of getting actionable data out of your first pass.
Yeah, look, I'm not going to lie. We played around with autographs. We played with Neo4j, and I wanted to cry for about 2 days afterwards. I was like, fuck that shit. So I went for D3, which seems to be a lot easier. It's been a hell of a journey trying to colorize it. The next step is to get some kind of legend working where I can start to step through to say, right, a key is generated there. It's using this random number generator. Oh, actually, there's a potential issue. That's what I'm hoping the next 3 weeks will pan out.
That's phenomenal. We do have questions in the chat, which is, are you looking for Entropy 2 from Tim Mather?
Yes, we are. That's next. So it's been pretty cool to work with Ben Rhodes over at Microsoft. He's in charge of all CodeQL and variant analysis, and he's phenomenal when it comes to this. And then the GitHub Advanced Security team. So yeah, that is on the roadmap.
Awesome. And then what is the conference you're going to present this at? I think a couple people missed it.
It's GitHub Universe next month in San Francisco.
Sweet.
Yeah.
And we got one more from Colby Bryan. Says, have you found them useful in following source to sync? What are the main pain points in the chain of development, and what would you like to do differently?
Yes, we definitely found it useful in following the source to syncs. I'm currently trying to build as many open source projects that make use of cryptography as possible so I have a better data set. What are the main pain points? Getting stuff to build. No word of a lie. It's unbelievable how hard that is. You'd think it would be really simple. No, it's not. You spend more time trying to get the thing to build and fixing build and compiler issues. And what I do differently, I think get community input first. Like what we're trying to do here is make something useful for everybody. So C-bombs are very important, no doubt about it. But also I think this is even more important. And community like feedback will be really fascinating here. Like, hey, I want to do X. Oh shit, never thought about that. Cool.
Very cool. Well, thanks a lot, man. This is fantastic. Looking forward to seeing it again.
Thanks, Daniel. Really appreciate it.